Hello everyone, welcome back. In this video, we will discuss how to target customers based on their behavior. And from here on, the course will be focusing more and more on analytics as we are transitioning from Excel basics to analytics. Enjoy. Hello everyone, welcome back to Marketing Analytics. In this video, we will discuss how to target customers based on their behavior. We will start by explaining how consumers are getting tracked online, and then I will explain two methods commonly used to target customers based on their purchase or online activities. The RFM framework, or recency, frequency, and monetary framework, and collaborative filtering, which is used to make product recommendations. First, a quick review of what we have discussed about two schemes to segment customers. So we have already talked about profiling, that is focusing on who the customers are. And in this video, our focus is on behavior, that is to explore what the customers do in order to segment them. We have all experienced a lot of changes during the age of the internet. One of the major changes for marketing research is the appearance of new forms of data. Here I'm going to talk about clickstream data. Clickstream data is usually recorded by marketing research companies. So the way this works is that first these companies would recruit a panel of consumers in the market, and once the consumers sign up, they will get paid to install a software on their computer or other devices. And then this software is like a plugin in your browser. It will be able to track the full browsing history of the user who has signed up, no matter how embarrassing the content is. So really, clickstream data tracks every single click, the full web visit history of consumers. With the flourish of mobile devices, another type of data has also been very widely collected. It's the geolocation data on mobile devices. And mobile apps, similarly, can track every single activity you have conducted on the app. So first, let me show you some information collected from clickstream data. Let's say we have 3 travel booking sites: Booking.com, Airbnb, and Expedia. And the consumers may go there to visit these websites before they book their trips. And for illustration purposes, here are 2 people. And based on the clickstream data, we know that person 1 has visited Airbnb once, twice, and then moved on to Booking, and then Booking again, Expedia, Expedia again, Booking, Booking again, Expedia, and then Airbnb, and assume this user eventually bought a ticket at Airbnb. Now there's a second person. So this person has visited Expedia 1, 2, 3, 4 times, and this user eventually bought the ticket at Expedia. So my question for you is, what will Expedia see on its own website between these 2 people? So here's what happened to Expedia. Expedia directly would not be able to observe the visits to Airbnb or Booking. So for person 1, Expedia would only see the visits to Expedia, and the history would look like this. So the person visits Expedia 1, 2, 3 times and did not buy from Expedia, and person 2 visited Expedia 1, 2, 3, 4 times and bought Expedia. And the most obvious conclusion, of course, is maybe a 4th time is a charm if this is all you see from Expedia's perspective. 3 visits, no buy, and 4 visits, a purchase. Obviously, there's a problem. If all you see is a user's visit to your own website, then you are missing the whole picture. And if you are using this incomplete browsing information to draw conclusions, your conclusions can well be wrong. So we know from clickstream data that person 1 was a bargain hunter. He had compared multiple websites. And person 2 was more or less a loyal Expedia user, and she visited Expedia only and bought the ticket. So the correct conclusion had nothing to do with the number of visits to Expedia, but more about whether they are visiting a single website or comparing across different websites. So obviously, knowing visits only to your own website is a problem. Can we just use clickstream data to solve this problem? Not quite. Clickstream data is expensive and it does not scale. When you recruit consumers to sign up for your tracking network, so these marketing research companies would have to pay the users to install the tracking software, and to maintain tracking, they have to pay these users every year. And maintaining them can be very expensive, going somewhere from hundreds of thousands of dollars each year to millions of dollars each year. And that is only to track a few thousand people. So this method is expensive and it does not scale easily. We have millions of internet users. And the technology companies have found the second best solution using a tool called cookies. Cookies is basically a small text file. It contains a piece of information that allows a website to record a person's comings and goings. So each time you visit a website, the website drops a cookie file on your computer. The next time you visit the website again, in that visit, the website can access that cookie information again to know that you are a repeated visitor. So some examples of applications of cookies include personalization, website tracking, targeted marketing, and a similar technology can be used on mobile app tracking as well. I mean, in a way, mobile apps are just glorified browsers. There are two types of cookies. So first, the easier to comprehend type of cookie is first-party cookie. They are site-centric. By site-centric, I mean you are Expedia, so you drop an Expedia cookie on the local computer. Using that cookie, Expedia can identify you are visiting its website. So this is the way it works. So Expedia, when you visit Expedia, Expedia drops a cookie and the website can access that cookie whenever you visit. So if you come back to Expedia the next time, and then the cookie is still on your computer, so Expedia would again be able to access that cookie to identify you as a repeated visitor. So now turning to the dark side of cookies, there is third-party cookie. And third-party cookies are user-centric in a way that they are not affiliated to a single particular website. It's not just for Expedia, it's for other websites as well. And an example would be the Google Display Network. It knows your web browsing history even if you don't use Chrome. So whatever browser you use, as long as cookie is allowed, Google Display Network can track you across different websites. So the way third-party cookies work is like this. Again, you visit Expedia, and Expedia drops cookies. But in this case, Expedia doesn't drop only its own cookie. Expedia also drops a third-party cookie. And this third-party cookie, let's say, belongs to Google's display network. This cookie is not just accessible by Expedia, it's also accessible by Google's display network. If you go back to visit Expedia again, Expedia would be able to see both cookies, its own cookie and third-party cookie. Google Display Network, on the other hand, would also be able to see the third-party cookie. Now, if you visit Airbnb the next, what happens is Expedia would no longer be able to access its own cookie when you visit Airbnb. However, if Airbnb is in Google's display network, Airbnb would drop a third-party Google Display Network cookie again, and the Google Display Network would be able to access that cookie. So this same cookie from Google Display Network now would be identify you as the person who has been visiting the websites Expedia, and then Airbnb. So third-party cookies are not just tracking visits to a specific website. They are able to track a very complete browsing history of users. That's why they are more user-centric. So in summary, for first-party cookies, each website only knows its own stuff. For third-party cookies, however, each website can have, through the display network, complete information of a user's browsing history. This, of course, is heaven for advertisers. However, it also causes various privacy concerns. And this is the reason why nowadays we are seeing the movement to move to a cookieless world. And one of the initiatives that Google has brought to the market is Chrome would start to phase out third-party cookies within a certain time frame in the next couple of years. And that would make a big difference in the whole ballgame of internet user tracking. However, this change is not that straightforward. Google has so far delayed the deadline for phasing out third cookies twice already. So we will see when it might happen. So now we have covered how internet users are getting tracked. Now we move on to activities that are even closer to the final purchase. So how about users' purchase activity or the content they generate online? How can we make use of that? And for this, we will introduce two analytics tools, RFM and collaborative filtering. And for both tools, we will have separate videos to introduce these methods using Excel examples. First, a quick example. Let's say I'm tracking consumers' purchasing activity at my retail business. And I'm looking at a time window from day 0, the beginning, to day 100, the end of the tracking period. And throughout this period, I can observe a user's purchase history. So let's say Andy. Andy has purchased 4 times over this 100 days. And his last purchase was on day 90. And his purchase events were somewhat spread out throughout this period of time. And here's a different consumer, Betsy. And Betsy has also purchased 4 times, but Betsy's last purchase event was on day 30. So simply comparing these two consumers, which consumer do you think is more likely to be still active with my retail business? Hold on to your thoughts. Here are 2 more consumers, Crystal and David. So from a most common sense perspective, if we were to predict how likely each one of these consumers are still active with my retail business, it looks like Andy is still active, and Betsy and Crystal are both very questionable, and David is probably more likely to be still active comparing to Crystal and Betsy. So why do we come to that conclusion? Because Betsy and Crystal both had pretty high frequency of purchase, and their last purchase events, however, was relatively far away. So instead of having more purchases over these 100 days, it seems like David may still be active, but Crystal and Betsy are less likely. And we come to that conclusion. Actually, we have unconsciously used the key pieces of information that we often use to manage customers in this kind of context. So one piece of information we have looked at is the recency. That is, what was the most recent purchasing event. And the second piece of information that we have used is actually what is the baseline purchasing frequency of these consumers. So this is really where the RFM framework comes from, where R stands for recency, F stands for frequency, and M is on top of recency and frequency is monetary. That is how much they are purchasing when they come to buy things. So using this simplified example, I'm sure you get the common sense idea of recency, frequency both matter, and monetary obvious matters. So that is the fundamental idea of using RFM as metrics to segment and manage customers. All in all, it's a very common sense based approach. There's nothing fancy here. It's just a matter of how we implement the RFM framework. So we'll see more specific applications of this in the Excel example. That's in a separate video. The second tool we're going to discuss is called collaborative filtering. And this is a method that's used in Amazon and potentially Netflix. I mean, they have more complicated tools, but the fundamental idea of the framework is not that different from the most simple version of collaborative filtering, which is what we are going to discuss and then separately using a video to show how to do it in Excel. So here is the context. Suppose we observe the data about the following individuals: Alex, Blair, Carter, Dylan, Elliot, Finley, and Gabrielle. So we have 7 people, and we observe their evaluation of 6 movies: Don't Look Up, Top Gun Maverick, Nope, Elvis, Minions, The Rise of Gru, and Black Phone. So 7 people, 6 movies. Obviously, we are using a very simplified example here. As you can imagine, this table can become much larger by having millions of users and thousands of movie titles and TV shows. So in this table, we have the movie titles here and the consumer names here. In the cross, each one of these numbers is a consumer's rating of a specific movie. For example, this number 4 here is Alex's rating of Top Gun Maverick, and 1 is Alex's rating of Nope. So the $1,000,000 question here is, how do we predict an individual's evaluation of a movie we don't yet know? And this can be an extremely useful piece of information, because if I know how much an individual may like a movie, then I can either make a recommendation of the movie in a context of Netflix. Then if users are happy with my recommendation, they'll be more satisfied with my service, and they are more likely to continue the subscription. And in a context like Amazon or a retail business, then recommending a movie that a consumer is more likely to enjoy would increase the probability of purchase. So this information is very, very useful. Now let's say within this table, we want to predict Gabrielle's rating for Nope, which we don't know yet. This may look like a mission impossible. However, we can think of some common sense approach. And for example, we know Gabrielle has rated some movies, although she didn't rate Nope. And then, what about the information within the movies that Gabrielle has rated? So for the movies that Gabrielle has rated, the more similar a movie is to Nope, and then the closer our predicted rating for Gabrielle of Nope should be to that movie, correct? So that makes a lot of sense. And on the contrary, if a movie is very dissimilar to Nope, then her rating for that movie should not give us a lot of information about how she's going to rate Nope. So more specifically, the idea goes like this. Let's say there are 2 other movies, movie A and movie B. And Gabrielle's rating for Nope can be estimated using a formula like this. So if we know how similar movie A is to Nope and how similar movie B is to Nope, then we can use these two similarities as weights, and using the similarity of A to Nope multiplied by Gabriel's rating for A, which you already know. And using the similarity between movie B and Nope, multiply that into Gabriel's rating for B, which we also already know. Then we add this up. And then, of course, we have put in those two weights. We just have to normalize this number, divide the whole thing by the sum of the two similarities. So as you see, this is simply a weighted average. There's nothing fancy here. So basically, we weight Gabrielle's rating for movie A and her rating for movie B, which you already know by how similar movies A and B are compared to Nope. So now continue on this formula we have created. So for this formula, we have given an example of only two movies. It can be expanded to more than just movies A and B. You can use as many movies as needed to be compared to Nope. If Gabrielle has rated 10 other movies, then we can put movies A, B, C, D, E, F, G, H, I, J all the way to weigh those ratings in order to predict her rating for Nope. So as you can see, this calculation is easily scalable to many movies. Now the question is, how can we find out the similarities among movies? How to figure out the similarity, let's say, between movie A and Nope, and the similarity between movie B and Nope. So for this, we're going to use the rating information from the other people. So next, let me explain how we calculate the similarities. To calculate similarity, we're going to introduce the concept of distance. By distance, I mean literally similar to the physical distance that we use every day. So let's say there are two dots here on the screen, and we want to know how far these two dots are to each other. We may measure it directly using a tape measure, or we may build a coordinate system to do this by having an x-axis and a perpendicular y-axis. And those two dimensions are orthogonal to each other. Middle school geometry, I know. So if we know x and we know y, what is the distance between these two dots? So we have that the square of the distance is equal to the square of x plus the square of y. So it's a fairly straightforward measurement. We have all learned that ages ago from the geometry class. So we are going to use that distance calculation to derive a similarity measure. And first, some requirements for similarity measurement. Number one, the higher distance square is, the less similar. So if the two dots are further away from each other, they are less similar. So the larger distance square is, the less similarity is. And second, if distance is 0, that is, if the two dots are sitting on top of each other, they are in the same location, that means they are extremely similar, right? So when distance square is 0, when there's no distance, then similarity reaches its maximum value of 1. So they are entirely the same. That's when similarity is equal to 1. And on the other hand, when distance is infinite, when these two dots are as far away from each other as can be, and then they are not similar at all, in that case, similarity is 0. So similarity in that case would be between 0 and 1, and 0 indicates no similarity, 1 means perfect similarity, and any number in between 0 and 1 indicates different extent of similarity. The higher this number is, the more similar these two dots are. So therefore, I'm going to use a formula like this. So similarity is equal to 1 divided by 1 plus the square root of distance square. So for this, the square root of distance square is really just the distance. So literally this is 1 divided by 1 plus distance. We can do some checking on this. First, when distance increases in the denominator, similarity would decrease. Second, when distance is 0, so if this number is 0, it becomes 1 divided by 1 plus 0. So similarity becomes 1. That's the number 2 we have listed out. Third, when distance becomes infinite, it's huge. It means the denominator 1 plus infinite is still infinite. So 1 divided by infinite is 0. It means similarity becomes 0. That's our rule number 3. So this simple formula would fulfill all our needs. That is how we measure similarity. Let me give you a more concrete example using the movies we have listed. So let's say I'm looking at a part of the table that I've shown you earlier. Again, we have 7 people, A, B, C, D, E, F, G. And here I'm only looking at 2 movies, comparing between Nope and Elvis. So I want to calculate the similarities between Nope and Elvis based on the user ratings out there. So my rationale is if the rating from different people on the 2 movies are similar, it means people have similar preferences to these 2 movies. If the ratings are more different from each other, it means these 2 movies are more different from each other. So the similarity in the ratings here that we already know is an indicator of how similar these 2 movies are. So here's the distance calculation. So the distance between Nope and Elvis is equal to each pair of ratings from the same individual. So 1 minus 3.5 and then take a square. So the more different this pair of ratings are, the bigger the distance measure is going to contribute to. So for this, we're going to have 4 pairs of numbers. So we have Alex rated both movies, Blair rated both movies, Dylan rated both movies, and Elliot rated both movies. So for each pair, we're going to do a difference in their ratings and take a square. Difference, 1.5 minus 5 squared. And here, because Carter didn't rate the movie, we don't have a pair to compare with. It ends up with nothing, so we don't calculate that distance measure, so it's 0. And then we have 3 minus 4, take a square, 4 minus 3, taking a square, and the last 2, again, there's no rating, so they end up being zeros. So if we add these things up, we end up with distance squared between these 2 movies is 20.5. And using that distance, we can calculate the similarity between these 2 movies. That is 1 divided by 1 plus the square root of distance squared. So that ends up with a similarity of 0.181. Not quite similar between these 2 movies. So once you have this similarity measurement, you can calculate this similarity between Nope and all the other movies, not just Elvis, but all the other movies. So once we have all the similarities between Nope and all the other movies, we can go back to the formula for predicting Gabriel's rating for Nope, and then we can put in those similarity measurements in this formula. Then we can create a predicted rating from Gabriel for the movie Nope. We will discuss in detail, step by step, how to conduct a collaborative filtering estimation in Excel. Thank you, and keep up the good work.